skip topic. And
go straight to what
you realize this system.
Okay. First, I will introduce the hardware part of our system. Okay. Skip. Next. We choose the basic step 2 servers as the brains inside of the electronics. This is the chip, the microcontroller chip, and we put this into this part. You can see the same size, and this is connected to our laptop or computer. We have to program into that, and this is connected outside these chips to generate our instructions to force our model cars to stop or to slow down and to maybe turn around just to avoid a collision. And then this is the power supply, 9 volts battery is here. Yeah. Yeah, because our laptop is not ready.
We gotta think of a USB or something, right?
Yeah, we can convert the connection, right? Sorry. Next, and this is the audio alert because we want to use this to make sound to warning the driver to focus on the driving, and this is going to make sounds when the car is driving get close to a barrier, and it will sound faster and faster when you get closer and closer. And when you get too close and you didn't stop, you will continuously. Yes. And this is the LCD display. We want this and the audio alert combines the user interface of our system. This we can see the distance here, and we can see the temp. The distance here and and the temperature here. Why we want to see temperature? That's because I'll keep it a secret because my teammate will introduce it. Why we need to know the temperature. Next. This is the ultrasonic sensor, and the working theory is very simple. Just transmit signal outside, and it hits the wall or something, it will turn back, and the ultrasonic sensor will catch it again and send it to our microcontroller. Yes. Oh, and this is how we connect our hardware together, and maybe we can make another connection to the ABS system because enough output. And my team member Motong will introduce the program part of our system.
Now I will introduce the design of our system. Look at this picture. This is a microcontroller, and we need 3 inputs and 2 outputs. One of the inputs is connected to the ultrasonic sensor, and the other one is connected to the temperature sensor. In the real world, we would use the temperature sensor as my colleague mentioned it earlier. Because sound waves that the ultrasonic sensor send it is affected to air temperature. And the last one is connected to the speed sensor. In the real life, if we drive too fast, we must slow down our speed earlier. However, our model car is driving inside, so we don't need the temperature sensor and the speed sensor. The 2 outputs are connected to the user interface. The user interface consists of the LCD display and the audio alarm. The range of the ultrasonic sensor is between 2 centimeter to 3 meter. set parameter in our output prototype to stop at 25 centimeter. When it detects an object, when the MCU begins to work, it asks from the ultrasonic sensor. The ultrasonic sensor receives a signal and begins to measure the distance between the car and the sensor, then transits to the MCU. The MCU will send it to both the LCD display and the audio alarm. After it's converted, the MCU will keep working until the car below down its speed into the safety distance. This is all the design of our system. Next, my teammate Wang Lu will give us some data which we can use in the real car.
I want to introduce the hardware and the software in the collision avoidance system, and in the model style, and I will add some problems system in the real car style. And there are two problems we considered. One is the speed and one is the relationship between the speed and the minimum safety distance in the real car style. This is different from the model car style. This is the speed of the real car, and those are the minimum safety distances corresponding on that. And these data come from the traffic control regulation of China. So we can use them to refer to the real car system. And the other problems is the relationship between the temperature and ultrasonic spreading, wave spreading. The different temperature will have influence to the wave spreading. This function shows their relationships. If we know the temperature the system in, then we can know the speed of the wave spreading. So we can write this function into the microcontroller to overcome the problem. Next, my teammate Shiqi will introduce the budget.
This is ultrasonic sensor. The reason we choose ultrasonic sensor because of the ultrasonic sensor uses ultrasonic echo to measure the distance between two cars. The time difference measurement is accurate. The measurement range is 0.02 to 3 meters. This ultrasonic sensor has a small blind area, and it's waterproof, anti-corrosion, and with low price. And this is the laser run sensor. It is dependent